Thank you very much for joining me. And it's great to be with you. Today, I'm going to tell you about what math are you teaching? A tool that we developed for individual and organizational analysis of math activities. And this is a group work done together with many of my colleagues here at the Davidson Institute of Science Education. So a bit about me. I'm a recreational mathematician. That means that I play with the world of puzzles, games, origami, and their connection to math. And it's something we've been emphasizing in our organization as a way to help people enter math in a very easy way, rather than being chucked formulas straight away or notation. And it's something we've been exploring. But let me tell you a bit about my organization. As I said, these are some of the books that I wrote. And our organization does many things. Two of these things that might be relevant for the audience watching us are some English activities in recreational math, and we have 4 online courses, which I'm proud to say have nearly 100,000 people who've registered to them. Now you might think, okay, these are massive online courses, MOOCs. We know that the dropout rate is, especially since it's free to join, is quite large, and that is true. But actually, close to 20%, that's close to 20,000 people have been active learners in these courses. What I mean by active is they've done nearly all the stages of the course, so they've more or less completed the course up to about 90%, something like that. And you might also like to see some of our TED Ed videos that also have been popular on learning math through puzzles. We also have non online activities such as our annual Puzzles, Games, and Recreational Math Festival, which happens outdoors in the spring, and you can see many of all the different kinds of puzzles. And this is the Davidson Institute of Education. We've just launched a new museum, the Clore Garden of Science. This is the math section, one of the math sections of the museum. And again, we do math and science education for everybody, really. K-12, kids in school, kids outside school, formal activities, informal activities, curricular, extracurricular. We work with teachers. We work with everyone. And we have many dozens of science and math programs. In some of them, as I said, online, some of them offline, some of them hands-on, like this work which another lab in our museum, which is a kitchen chemistry lab. So kids can, or anyone really, can do chemistry in the kitchen. We have a complete kitchen, but they're doing chemistry in it. We have a multimedia setting where there's 270 degrees immersive space where kids can pretend or feel like they're inside perhaps a rocket, a spaceship, and see what they see there. We have a planetarium as well. And our online activities include, as I said, videos and stuff like this. This is the layout of the Garden of Science. And just a few more pictures here, including perhaps this one, which again, it's something really new. It's a coding place inside this pavilion here. There are blocks where the public can actually code the mathematical function, which is used by the sprinklers to sprinkle water. So you can really design everything. Here's a short video. I'll give you another bit. When I've taught you quite a bit about our organization, and the reason I did this is because being a large science and math organization, it's important for us to understand, for science, but for math in particular, which is my area of expertise, what math are we teaching? What do I mean by that? We have many programs, curricular programs, extracurricular programs, programs for underachievers, programs for gifted students, programs for that are long-term, like online courses, short-term activities, maybe a visit of family in the Garden of Science for maybe an hour or two, and they may want to go to the math exhibits there. Online, hands-on, again, science museum. But apart from the science museum, we also have many programs outside the science museum, inside laboratories, outside the campus, where we go to them, K-12. As one of the organization's policymakers, especially in the area of math, we needed a way to assess all these different programs and how they were dealing with math, because we wanted to make sure we didn't even know what math we are teaching. We decided this online tool to do this, which is divided into 3 questions: what, how, and why. And each of these questions, we had a scale, and the scale, we asked each of these different programs to place themselves on this scale as to what content they are teaching, whether it's curricular or non-curricular. Some, whether it's mathematics or meta-mathematics. So what do we mean? Curricular, obviously, if it aligns with the K-12 curriculum. Non-curricular, if it's completely outside the curriculum. And of course, there can be cases in the middle where the content of the course is something which is aligned with the curriculum but expands upon it. The same goes to mathematics and meta-mathematics. When we speak about mathematics, we want to know, just math topic, geometry, algebra, whatever. But when we speak about meta-mathematics, then this encompasses the history, epistemology, sociology, and of math and its role in society. So these are kind of the things that we deal with when we speak about mathematics. So what are the programs? How much history of math do they include in the content? So these are the 2 aspects we chose to focus on in the what section of our tool. We decided to restrict the number of things we ask in each section to get to really the basic the basic things we want to know, because we really wanted all the programs to fill in. When we asked them how they teach their programs, there were two aspects. One is rigorous versus narrativistic, and the other is passive versus active. So passive versus active really means hands-on. Active is hands-on activities. So perhaps with math, you might think of an origami club, where there's a lot of hands-on there, Mobius strip activities. And when we speak about passive, these are lectures, basically, like what I'm giving you now. Rigorous versus narrativistic is perhaps, if you think of the way we teach, maybe very formalistically in school. So rigorous means you, if you want to teach proofs, you teach the proof very rigorously, from the basics, from the axioms. There's a very clear way that this is done, maybe following Euclid's elements. When we go to narrativistic, this turns math into a story, okay? For example, even take the example of proofs. The Pythagorean theorem, we can explain narrativistically using different kinds of proofs, using different kinds of, there's even a museum exhibit. You probably know of these, where it's where you can see the actual, where the Pythagorean theorem is proved by liquids moving in, being poured from different shapes, from squares into the triangle. So these are the three, these are the two hows. And the two whys are for what purpose are we teaching it? What do we want to achieve? It can be intrinsic versus instrumental, and it can be in-depth versus broad. So in-depth means that we take one topic, we take one topic in math and drill right down into it, symmetry, for example. Learn everything you want to know about symmetry. Or it can be broad, a bit of this, a bit of that, some puzzles, some games. Intrinsic means we learn the math, or we teach the math, because we believe in the intrinsic value of learning math. So the topic really doesn't matter. What we learn math for the sake of math, whereas instrumental means we learn math or teach math in order to do something, to invent something. It can help us understand the world. So each of these programs used the tool and had sliders to choose where they are along the in each of these. And you can see it goes from the main feature to somewhat, slightly leans forwards, slightly leans forwards, and to the main feature of the two different extreme points. And each color is for one of the different questions. So what is red, how is green, and for what purpose is blue? And once we've done that, for every different program, you can get a broad view of what math gives us. So this is just a chunk, because we have perhaps 50 programs, maybe more. So this is only a chunk of them, but we can see that just by looking at, for example, for the what, we can see that nearly all our programs have a diagonal going from left to right. Okay, so this means that we mostly teach non-curricular mathematics. We might want to rebalance this when we are over the organization. Okay. If we take a look at the blue, that seems much more versatile. Okay. And perhaps the same with the red. So again, this is just an example of an interesting way that we can evaluate our programs and understand what math we are teaching. And the way we assess the programs, of course, it's something that can be done in either way. You can ask the programs themselves to evaluate themselves, or we can do it for them. We can send a specialist in to work with them. And that's it. I'd like to thank you on behalf of all of my colleagues.